So in this video we will see how we can add a task into a subgroup or into a C group. So the task which I have decided to add is HTTPD. Okay. So before I move further, let me show you the current system status. So as you can see, this is the hierarchy which I have created, and these are the subsystems which are mounted on this hierarchy. And this is the subgroup which I have created, or the C group which I have created, and CPU set, CPU account and memory, these are the subsystems I have attached to the subgroup. Going next, so if I look into the since as of now I have not started the HTTP process, so let me start it first. Service HTTPD start. The process has been started. As you can see, these are the processes which has been started. So there are near about 2, 3, 4, 5, 6, 9 HTTP process started. And as we all know, every the moment you create a hierarchy, or the moment you start a C group service, all of the tasks running on that system will be a part of every subsystem. So that is what happened with the HTTPD as well. So manually we haven't added a HTTPD process in any subsystem or in a C group, but still every HTTPD process becomes part of every subsystem. You can see BLKIO, NetCLS, freezer, devices, memory, CPU account, CPU and CPU set. So this is our hierarchy. So HTTPD by default become part of it, as well as these are the other subsystems which we have mounted on the default path. It also become a part of it. So every HTTP process become part of it. Okay. Going next. So the point which I want to make here is the moment you start the moment you start any task at this moment, it will become a part of all of this subsystems, as well as this CPU and MEM hierarchy. I'm going next. How can we add a task into C group? That we can add through a cgclassify command. But before I move a task into a C group, it is always recommended to first set the tuning parameters and then move a task accordingly to a C group. So how we can set that is through cgset. So cgset -r, CPU set is the subsystems, and CPU set CPUs is the tuning parameter. I want to set it to 0, and then I want to add it to the test subgroup. Test subgroup. Okay. So what will happen here? So the test subgroup will be able to access only CPU number 0. This system has two processors. As you can see. Out of that, the test subgroup, which is C group, will be only able to use a CPU number 0. At the same time, I will set the another tuning parameter, which is a memory node. The way we have set test subgroup, we restricted test subgroup only to use CPU number 0. The same way it will use only memory node number 0. Okay, let's set it. We can cross verify the settings from cg snapshot-s. If I grep it for the CPU set, you can see here this is not set. So what I'll do, I will CPU set mems. Okay, I made a mistake here. It should be mems. Okay, so let me cross verify. As you can see here, these are the two tuning parameters which we have set. So what exactly does that mean is, if I add a HTTP process now into a test subgroup, or a C group, the HTTP process will only be able to use a CPU number 0. That's how it is. Okay, so before I add HTTP process, let me show you the task files of the CPU and MAME hierarchy. There's so many number of tasks added into the list. So before that, let me show you the PIDs. So let me just grep it for this 18594. So the process are basically starting from 185. So let me just grep it for grep it for 185. As you can see, we haven't added a HTTP process into the CPU and MEM hierarchy. Still, all the HTTP processes, for example 18594, for example 18595, 6, 7, 8, all are part of this hierarchy. At the same time, for example, if we check it with the BLKIO, C group BLKIO task, and if we grep it for the same PIDs, you will find the same PIDs are also part of BLKIO. Now let's use the cg classify command. The moment I use the cg classify command, through cg classify command we will add one of the HTTP process into a test subgroup or a C group. So cg classify, we need to specify the subsystem, so I'm specifying CPU set as of now. So CPU set subsystem, we are adding to test subgroup, and the PID I'll choose 18595 PID for here. This will be, ideally this should be added into the test subgroup, this PID. So let me repeat the same commands now. So 18595, I'm checking into the BLKIO. Now it shouldn't be there. Okay, since we moved a 18595 service to the test subgroup, to the C group, so it has to be removed from every other hierarchy or a subsystem. 18595. Oh, we haven't added the BLKIO. We haven't attached the BLKIO to the test subgroup, so it will be available. But if I check the CPU inside this hierarchy, yes, inside of this hierarchy 18595, it shouldn't be present, as you can see. Okay, but it should be present into CPU and MEMS test subgroup tasks, as you can see it here. And now if I check the PS commands output, as you can see, HTTPD is still a part of all those HTTP processes. Some of the processes are still part of these subsystems. For example, let's talk about our 18595 service PID. It's still a part of BLKIO because we haven't attached this BLKIO to our test subgroup, so it will be part of it. Same with the NetCLS, same with the freezer, same with the devices. Now, as you can see, memory, CPU account, CPU set are attached to the CPU and MEM hierarchy, and inside that test subgroup has been created, and our HTTP PID become a part of it. This is how you add a task into a C group.